Our goal in this section is to construct regression models, which then we can use to make predictions. But before we start that process, before we construct a regression model, first thing we need to do is verify that a linear association does in fact exist between our two variables. Once we demonstrate that, then we can construct the model and look at predicting and calculating residuals. Residuals are what we're going to look at to basically assess the error in our model. So since we're making predictions about future unknown values, those are never going to be perfect. So there's always going to be some amount of error. So in addition to looking at any predictions we won't make, we also want to consider any residuals in our model, which we'll take a look at. In example 3 here, we have information on average market share for Internet Explorer and the homicide rate in the United States. So throughout these videos, I like to make use of examples that seem sort of absurd, especially in that sense of thinking that association implies causation. So if there's an association here, a positive association or a negative association, it would mean that you using Internet Explorer as your browser has some effect on the homicide rate in the United States, which doesn't make any sense. So again, we're kind of just trying to reinforce that idea that correlation doesn't imply association. Association does not imply causation. Finding an association can be helpful information if you have two variables that sort of seem like there might be some cause and effect relationship, but you'd have to do more research beyond this, set up some more stringent experiments to prove that causation relationship. So just always keep that in mind. We're not looking at causation, just if there's an association. So the first thing we want to do is find the linear correlation coefficient and determine if these variables share a linear association. So we've already done this by using stat, summary stats, then correlation. But since we're also going to construct a regression model, we can use the regression tool and select simple linear. We'll pick our two values, our two variables, and click compute. So the advantage to this is it's going to give us that regression equation, assuming that there is some association, and it's also going to give us our value for capital R, which is that correlation coefficient. So in this case, a correlation of 0.9477. So the correlation coefficient is R equals 0.9477. Suggesting that these variables share a strong positive linear association. So since there is a strong association, or some association, then we can go ahead and construct our linear regression equation, or that linear model, which again, the same screen is already output for us. So in this case, we could say the linear model, or regression model, is y equals 3.452 plus 0.031x. And we're not asked to, but we could provide an interpretation for the slope. So as Internet Explorer market share increases by 1%, the US homicide rate will increase by 0.031%. Or if we wanted to flip that around, in this case what we see is that the market share for Internet Explorer is actually dropping each year. So is the homicide rate. So a positive association just means that those variables increase together. So we could say, or as the Internet Explorer market share decreases by 1%, the US homicide rate will decrease by 0.031%. So positive association just means that those two variables change in the same way. Both increase or both decrease together. So we know there's an association. We have a model. We can start predicting some unknown values. So let's say in a coming year, Internet Explorer's market share will drop to 28%. we want to use that to predict what the US homicide rate should be. So we can refer to our model, y equals 3.452 plus 0.031, and then in place of x, we'll plug in this value of 28%. So that gives us a value of 4.32, meaning that if Internet Explorer's market share drops to 28%, then we would expect the homicide rate to drop to 4.32%. So that's our predicted value. We don't know if that's true, but based off the data we have, that's what we would expect to see. So when we make these predictions, we know that that number isn't 100% accurate. It's going to be a little high, it's going to be a little low, but if we have a good model, that should be relatively close to what we would see. So let's take a look at a predicted value versus an actual value that we know. So we know in 2009, the market share was 56.13%, homicide rate was 5%. We want to use our regression model to predict the homicide rate given a market share of 56.13%. So we know the value should come out to be 5 because that was the actual value that occurred. So if we calculate y equals 3.452 plus 0.031 times this value of 56.13, in this case we would get 5.19203. So as a last step, let's find the difference between the observed value, which was the 5%, and the predicted value, which was the 5.19203%. So we would take our observed value and subtract the predicted value, to get an error or a residual of negative 0.19203. So that difference between the observed value and the predicted value is called the residual. And those residuals help us understand how accurate our model is by measuring the error in our prediction. So in this case, our error is relatively small. There's not much difference between this known value and the predicted value. Meaning based off this value, it seems like we have a pretty good model. It's a good fit for that data, meaning this future prediction that we don't know of 4.32% for the homicide rate is likely to be pretty accurate. But one thing to keep in mind is we can only calculate residuals for our known values. This value that we calculated, that 4.32%, there's no way to verify how accurate or inaccurate that prediction is until the market share actually dropped to 28%. And then we could make that comparison between our prediction and reality. So we have to look at the values we do know, calculate those residuals to see how good or bad our predictions are, and use that to infer whether or not we think our future predictions are good predictions or not. So, and one last time, keeping in mind the idea that association does not imply causation, because if it did, then we're saying that using Internet Explorer versus Firefox, Google Chrome, something else, would actually cause people to be murdered. So again, common sense would just say there's no way, probably, that those two things have any relationship whatsoever. They just happen to change in the same way. They both increase together, both decrease together.